In the framework of the digital twin project between the University of Transport and Communications in Hanoi and the Middlesex University, I will address some points of interest. First of all, what are recent developments in sensoring techniques in structural health monitoring? The general tendency is higher sensitivity, more robust sensors, more accurate sensors, and full-field measurements. When we speak about vibration-based structural health monitoring, still accelerometers, velocity meters, and inclinometers are the most used. But in recent years, there is especially interest to measure directly displacements. Could be by high-grade GPS sensors, also techniques like pattern interferometry or laser Doppler interferometry could be used. Also interesting is photogrammetry. You use a single or multiple cameras, and then you treat those results with digital image correlation for full field displacement reconstruction. Also, radar systems have been used with success. More and more, also unmanned aerial vehicles are used for bridge monitoring, and they can also equipped with vision systems. Also, a recent trend is to use photonic sensors, especially fiber Bragg rating strain sensors, which can measure accurately strains in a lot of sensor points. Let me speak now also about vibration-based damage assessment. There you have on one hand non-model-based methods that read the data in a stochastic way and try to distinguish between changes due to temperature and changes due to structural damage. But more powerful are the model-based methods, and the digital twin structure is adapted in this case to the measurement results. And continuously you're adapting your digital twin based on the output of your sensors. For this adaptation, you can use optimization, or let's say minimization methods like particle swarm optimization or genetic algorithms. Now let's illustrate this by a recent example, the new Morandi Bridge. As you know, the Morandi Bridge has been destroyed in August 2018. And in this case, the new bridge, which is called the San Giorgio Bridge, was already foreseen from sensors right from the design of the bridge, which is the best case, the ideal case. Design your bridge immediately with the monitoring system. In this bridge, more than 100 internal sensors are installed. Accelerometers, extensometers, velocity meters, inclinometers, and detectors for joint expansion. They will track the vibrations at several points, as well as to measure the deformation of the road surface. A large part of the sensors will be supplied by a Dutch company, Somni, specialized in photonic sensors. The big advantage of these photonic sensors is that they are connected on the same fiber optic cable. So instead of using for classical sensors kilometers of copper wire, you have a lot of sensors just on one optical fiber. Also, when compared to wireless sensors, which are also very interesting, but then in this case you need batteries, and also these wireless systems ask for a lot of maintenance. So there again the photonic sensors have clear advantages. In the case of the Morandi Bridge, I'm treating this case especially. The lights and the sensors are powered by solar panels installed on the bridge. And there are robot devices along rails on the bridge edge to clean the solar panels and also to provide extra monitoring. Also, as part of the monitoring system, cameras are used, which are in connection to sensors on steel plates at the bridge deck to measure the loads transferred to the bridge. Also, a project called Simon was attributed to two Italian companies, Foss and Cetina, and the aim of this project was to develop a digital twin of the new bridge. So the old Morandi Bridge is replaced by the San Giorgio Bridge, and a digital twin was immediately envisaged. So Foss will develop the acquisition software, and Cetina will develop the digital twin, which is continuously adapted according to the measurements. So this example of the new Morandi Bridge shows that the digital twin project between UTC and Middlesex University is really in line of the most recent developments in structural health monitoring. It will certainly contribute to better management of bridge infrastructure in Vietnam.